Greetings, welcome to the second half of practice problem 6 from lesson 9.3. Here we're going to look at B, C, D, and E. So again, we need to solve the following quadratics and then verify them graphically. So they want us to use the quadratic formula in every one of these. So in order for us to be able to use the quadratic formula, we need to have it in the form of ax squared plus bx plus c is equal to 0. And then we need to come in, once we've done that, identify the values of a, b, and c, and plug those into our old pal x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, all right, so let's come in. First thing we got to do is get it set equal to 0 to identify a, b, and c. So rearranging this one, it would be 2x squared minus 5x minus 4 is equal to 0. So a is equal to 2, b is equal to negative 5, and c is equal to negative 4. Very important you keep the sign with the number, okay? So that means that x is equal to the opposite of b, which is the opposite of negative 5, plus or minus the square root of b squared, which is going to be negative 5 squared, minus 4 times a, which was 2, times c, which is negative 4, all of that over 2 times a, all right? Okay, so that's going to give us 5 plus or minus, notice negative and negative gave us a positive. Okay, now let's go ahead and let's do this part here in our calculator. In other words, let's make our lives a little bit easier here, and let's go in and do the stuff under the square root, which is actually has a name called the discriminant. Let's do that on our calculator. Because if you're going to make a mistake in this problem, that's probably where it's going to happen. And so if I make sure I do that number correctly, then the propensity of everything else to come out right usually goes up dramatically. So we've got negative 5 squared minus 4 times 2 times negative 4 comes out to 57. This was also a 2 times 2 down here. I got an A, so let's make that into a 2, which gets me back a 4. So we get plus or minus the square root of, don't need quite that big of a square root. There we go, square root of 57 all over 4, okay? Which means if we go for the two solutions here, that x1, the positive one, is going to be equal to 5 plus the square root of 57 over 4, and x2, which is the negative one here, the pessimistic one, is going to be 5 minus the square root of 57 all over 4. Okay, so let's go get these in the calculator and take a look at it real quick. So go to the y equals, clear out all the craziness in y1, and we will put in 2x squared minus 5x minus 4 into y1. We'll hit a zoom and a standard and see if that works. See if we see our 2 points of intersection. By Jove, we do. It's looking good. So let's go second calc, and let's go ahead and use number 5. We'll do the intersection here. Make our lives easy. So we'll go first curve, second curve, best guess, and it looks like negative 6.374, blah, blah, blah. Let's see if that's close to being our x2. So we'll go back out to the home screen here by doing a second and a quit. And let's go parentheses 5, subtract the square root of 57, one more close parenthesis there, divided by 4. So the last thing that we did in the calculator was look at it, the last thing we did on the graph was look at that point on the graph, and we'll take a look at the x value. Oh, look at that, they match perfectly. That's huge. Okay, so I'll let you go ahead and check the second one on your own, but you'll see that that one's going to work out also. So going back to graph here for just a moment, notice it looks like we get a graph that looks not quite unlike, but similar to this, where that is x, that is y, and then you want to go negative 10, 10, negative 10, 10. The reason for that is you want to make it so that if I wanted to or somebody else wanted to come in and recreate your work, they could do that.